Alright, I know this is messy, but bear with me here. This is the ESP32. We got an INA266 with the built-in shunt removed. It's connected to the 750 amp shunt. This is the inverter I was building. It's all like the gates are just shorted. I'm only using the capacitor on this as an output capacitor. Okay, so here we have connected to it, we have a 5 amp 12 volt lamp and this starter motor from an outboard. I don't know, it draws a lot. So the wires here are this green one. This is the voltage sense for the INA266. So this is that first measurement you're seeing there. That's the output. That's what this capacitor, that's what this is holding here. The target voltage is selected by the potentiometer. As you can see, it's a little fidgety because it's a pretty bad potentiometer, but you know, it tries to reach that, you know, as close as possible and maintain it. The current, it's not too accurate right now. I'm still trying to dial it in, and the duty cycle is, well, that's a duty cycle that it's running right now. So if I were to, you know, slow the motor down, you would see that the duty cycle goes up to maintain that voltage. Right now you have this wire. It's just connecting the common ground so that the INA266 can read the bus voltage. Then these two wires, these are the ground and the gate drive. So that's a PWM output from the ESP32 It goes into this, which is the gate driver. You know, it's not even warm to the touch. I mean, it is warm to the touch, but it's not hot whatsoever. You know, it's been running for like 2 hours straight now. This is a 6.8 ohm gate resistor. The gate drive output goes directly into the gate. This is the overcurrent sense for the saturation current, or whatever it's called, for this for the driver. Since I'm testing, I just have it shorted out here to the emitter, so it thinks the voltage is 0 across, so it doesn't like throw any events. And then of course here, this is gonna be the output for the ESP266 with an interrupt. If it ever reaches over current, it can, you know, shut everything down before anything crazy happens. So, you know, these cables are obviously pretty long and I'm missing quite a bit of capacitors. I need a filter capacitor over here. Right now I'm using like this old like starter capacitor, which obviously they're really bad with ESR, so that's not providing the filtering that I need to, or that I'd be happy with. But basically, this is the positive input right here, this is a negative input, and this is a negative output, right? So you connect your load here and here. So this is positive and this is negative, and you're switching the negative because that's how these IGBTs and most IGBTs work. But yeah, this is the positive from the power supply, the negative from the power supply. These cables are a lot thinner than they should be, so you know, that's also, you know, contributing a lot to the noise and interference that's going on here. And so these are the snubber capacitors. I have them basically in series, you know, across the entire IGBT. I know there's some, you know, they sell some modules that it's like one big capacitor, but it has like two in the middle, you know, two in series built in that goes. But you know, I don't have any. These are the ones they took off from there for testing. The thing I'm not too sure about is that right here, right, this is across the collector and emitter. So when, you know, you send the pulse for this switch to turn on, you know, close, you're creating, you know, a massive current going through here. You know, you're basically shorting out the IGBT. So I'm not sure, you know, how much capacitance I can put, you know, on here if I can put more, because this massively reduced the ringing, albeit there's still, you know, here is to show you. This is the output right now. So you can see this is right, it's centered 2 volts. So you can see it's like, on average, it's like plus or minus 0.5 volts around there, you know, and this is around like a 10% duty cycle. You can see if I, you know, if I slow down the motor, you know, the size increases, because obviously, you know, it's trying to maintain the voltage. But if you see overall, you know, it does a really good job of actually, you know, maintaining the voltage at what you want it to be. If I increase this, you know, 5.75, you can see, and it just works. And there seems to be, you know, the problem seems to be mainly in the low duty cycles. You know, right now it's at 15%, but once you go over like 60 or so, here, just to show you. Okay, let's say you want a 10.25 volts. You see it stabilizes that right there. We're at 62% duty cycle, and you can see it is much smoother. You know, if I zoom in again, to have it at 2 volts, you know, it's there pretty much. We're getting there. But if I were to put I don't know, this capacitor, I'm gonna end up blowing it up here across the collector and emitter. You can see right now we're drawing 200 watts from the wall. See, the leads are gonna heat up because this is, you know, you're putting literal, like, just pure ESR into. Okay, I was having some technical difficulties here. So what I was saying, at low duty cycles, you know, under like 50, it begins to have problems that it's super noisy, right? So this is a 470 UF capacitor. I'm gonna end up throwing it away because I'm gonna damage it by doing this. But this is just to show you, right across the collector and emitter, right? So every time the collector turns on, this capacitor, you know, is being charged or discharged, you know. But look, that is without the capacitor, and this is with the capacitor. See? Hold on, let me. Alright, without, with, without, with. So now the problem is that you know, again, my understanding of all this stuff is very, you know, trivial, I guess. I'm not an expert in any of this. I'm just a random dude in his garage, you know, messing around. But I purchased a pair of these more on eBay, but they're much bigger ones. They're 20 microfarad ones. They're huge. They cost me $10 each. That's a good thing about all these power electronics, that you can find you can find them used on eBay for nothing, right? But yeah, this is it's hot. I'm not gonna say it's not, but again, I'm still dialing it in. But overall, I can push. You can see that lamp turning on and off. But yeah, you see that low duty cycles. You can we're at 2 volts right now, so on average, it seems to be spiking a lot more in the positive direction than the negative. But just centering it here, you can see you have plus 1 volt peaks and 0.25 volts in the negative direction. So it's very noisy, but it's not that much ripple, especially considering that this is designed to run at hundreds of volts rather than just 50 or 48 or whatever you want to. But yeah, right now you see the voltage, it does a very good job, considering how noisy it is right now. Right? Considering how noisy that is, it is perfectly stable, right? I slow down the motor. You see, it drops down and it does exactly what I want it to. But yeah, it's still, I have to do a couple things. The current control, right now I actually have the reaction time a little slow. So if I do this, you see, it ramps up slowly, because since I don't have a current control, if I accidentally short something out, at least I'll have time to just yank it or whatever, because I'm not trying to blow up this IGBT.